Hi. So for question 8, we're told a lorry is driven between London and Newcastle. In a simple model, the cost of the journey C in pounds when the lorry is driven at a steady speed of v kilometers per hour is given by the following equation. And for part A, we've been asked to find, according to this model, the value of v that minimizes the cost of the journey. Okay, so how are we going to approach this question? The best way I can explain this question is by drawing a graph. Okay, so what I'm doing is I'm plotting the cost against the speed. Okay, the cost in pounds against the speed in kilometers per hour. Okay, this red line shows a function and it's just arbitrarily drawn just to give an idea. And what we want to find is the minimum cost of the journey. Okay, so that's going to be given by differentiating and equating to 0. Okay, when dc by dv equals to 0. This will give us the point at which c is minimum. Okay, so I'm going to start off by rewriting my function, and I'm going to use my knowledge of indice laws now to bring up that v and say that c is equal to 1500 v to the minus 1 plus 2v over 11 plus 60. Okay, I can now therefore say that dc by dv, differentiating with respect to v, times by the power and minus 1 from the power. So we have minus 1500 v to the minus 2 plus 2 over 11. Okay, 2v over 11 differentiates to 2 over 11 and 60 differentiates to 0. Okay, so constants will always differentiate to 0. Okay, so I know that the minimum occurs, so the minimum value of c occurs, as I explained before, when dc by dv equals 0. Okay, so what I can therefore say is that I can equate the gradient function to 0. Okay, so I can say because because dc by dv equals 0, minus 1500 v to the minus 2 plus 2 over 11 also equals 0. Okay, so now it's just going to be simply about rearranging this equation to solve for v. Okay, and that will answer the part 1. Okay, so now I can therefore say that by adding 1500 v to the power of minus 2 on both sides, that 2 over 11 is equal to 1500 v to the minus 2. Okay, and again, using my knowledge of indice laws, I'm going to bring this v to the power minus 2 down. I'm going to say this is equal to 1500 over v squared. Okay, should be familiar with manipulating indices in that fashion. So what I'm now going to do is I'm going to times both sides of this equation by 11 and times both sides of this equation by v squared. Okay, so I should find that you get 2v squared is equal to 16,500. Okay, so now I'm therefore going to say that v squared is equal to 16,500 divided by 2, which turns out to be 8,250. And now I can finally say that v is equal to the square root of 8,250. Okay, so if you simplify that, if you put that into your calculator, the calculator will simplify it for you, and it comes out as 5 root 330. Okay, and this is v, so this is speed, and for this question the speed is in kilometers per hour. Okay, so we found the minimum value of the speed. Excuse me, we found the value of the speed that minimizes the cost of the journey. This may necessarily not be the minimum speed. This is the value of the speed which minimizes the cost of the journey. Okay, so that's part 1. What I can also do actually, before I move on to part 2, is I can express this as a number 90.83. I can express it kilometers per hour to 2 decimal places as well. Okay, but it's always good to have an exact answer. Okay, especially if I'm going to take this answer forward like I'm going to do in part 2, I'm definitely going to use the exact value. Or if I wasn't able to get an exact value, I would truncate this value and I would use 90.83 and maybe to 3 or 4 decimal places after that. Okay, so I can ensure that I retain the accuracy. Okay, so for part 2, we're asked to find the minimum cost of the journey. The cost of the journey is given here. We know the minimum value of v, so we're simply going to substitute this value into our equation. Okay, so c is equal to 1,500 over v, which we know as an exact value is 5 root 330, plus 2v, 2 times 5 root 330 again, over 11, plus 60. Okay, so when you put that into the calculator, you should find that you get a value of c as £93 and 3 pence. Okay, so we need to remember that c is in pounds, so we only give it to 2 decimal places. Okay, and that's part 2. So if you're having trouble with differentiation or any questions like this, do check out the links below in the description, where they will forward you on to many other videos on solutions like these and tutorials for this topic. And don't forget to like, comment and subscribe. Let me know what you want to see from me in the future, and I will see you in the next part.